times in calculus, the complicated functions are just transformations of other graphs. So for these examples, I'm going to use y equals x squared. Okay, this is my base function. Now suppose I want to raise it up so that the vertex is no longer at 0, 0, but it's some 0a. So if I want to move it up, then the function becomes f of x, which in this case is x squared, plus my a units. Well, if I want to move it down, I'm going to subtract off those a units. So if this is negative a, this is y is x squared minus a. Now suppose I want to move it to the left or to the right. Now let's think about this. Suppose I want to move it to the left. Let's suppose I want to move it to this point right here. Let's call this minus a. All right. So I'm going to take the whole graph and I'm going to move it this way. It turns out that you add a to x in the function. Let's look at this. Where does this have a vertex? This has a vertex at x equals minus a. Where if I wanted to move it to the right a units, I'm going to subtract a off. Now where does this have a vertex? This has a vertex at x equals plus a. And we're going to pretend like I can draw. Now suppose we want to vertically stretch or vertically shrink. Both of these have the same function. Form y equals a times f of x. So in this case, it's x squared. Now, it's a stretch when a is greater than 1, and that makes sense. This will actually tend to make things taller or narrower. And the shrink is when a is between 0 and 1. Another thing we do is a horizontal compression and a horizontal elongation. Now, think about this. A horizontal compression is the same effect as a vertical stretch, and a horizontal elongation is the same thing as a vertical shrink. So let's look at this. F of x is ax, so y equals ax squared. This is our base function. So this is a squared x squared in this example. So we'll have some sort of horizontal compression or elongation based on whether a is greater than 1 or less than 1. Now the last thing we need to look at is reflecting across the x and y axis. If I just have minus f of x, this is a reflection across the x-axis. So if I put in minus y equals x squared, well, what's another way I can write this? Y equals minus x squared. This is a reflection across the x-axis. While if I reflect across the y-axis, in this case it's very straightforward, y equals minus x squared, or just x squared. Now most of the times this isn't going to happen. We don't have such pretty functions.